Hello and welcome to this solution video of paper 21 mathematics 2 of A and AS level mathematics Cambridge International Exams. If you like this video, please share with your friends, give it a thumbs up. I'm preparing this video on demand of one of my subscribers. Let's go ahead with question number 1. Use logarithm to solve the equation 12 to the power x equal to, let me rewrite this properly, 12 to the power x is equal to 3 to the power 2x plus 1. Give your answers to 3 significant figures. Whenever we have such a situation and the bases are different, we may use logs so that these x's become the coefficients. What I mean to say is this. I will write log in front of the left side and log in front of the right side also. Okay, so whenever we have logs, the exponents can be written as the coefficients. So it becomes x log 12 equal to this 2x plus 1 will become coefficient. So 2x plus 1 log and 3 will be remaining here, log 3. Now our purpose is to find the value of x, because solve means find the value of x. We have an x here, we have one x here. Let's combine these two somehow together. So we'll keep it as it is because it is in expanded form only. But this one can be written as 2x log 3 plus 1, 2x multiplied by log 3, and 1 is also multiplied by log 3, so log 3. Okay, so let me bring this to the left side so that it becomes negative. So x log 12 minus 2, let me bring just like I brought these exponents at coefficients, I can bring both the coefficients as the exponent again or one of them. So I'm bringing this 2 as the exponent of 3 so that x is alone. My purpose is to keep x is alone. So this 2 becomes 3 square. So it becomes x log 3 square, and we are left with log 3 here. So x is common in these two, so I will write x common, and what is left will be inside log 12 in this minus log 3 square, which is log 9 in this, equal to log 3. And now we can divide both sides by log 12 minus log 9. Here also log 12 minus log 9. Purpose is that this log 12 minus log 9 cancels with this one, and we are left with only x, and we can use this to find our solution, which will be the value of x. So let me do it with my calculator. By the time I do this, I again request you to please subscribe to my channel and like this video. So what I got was x equal to 3.818841, but their requirement is 3 significant figures. So 1, 2, 3, we have to round off till here. So answer will be 3.8, and because of this 8, this one becomes 2. This is the answer of question number 1. Moving on to question number 2. Okay. Question number 2. A curve has equation this. Okay. Find the equation of the tangent to the curve at point this. This is given. Okay. There was no need, but they have given the y coordinate, which is good. We don't have to find out. Give your answer in this format, blah blah blah. So we know the equation of any line, not only tangent. Tangent is a line, right? So I will write equation of tangent will be what is the equation of a line, and because they want this format, I will use this y minus y1 equal to m x minus x1, where y and x are general points, general coordinates, which is this x and this y, so we will not touch them. y1 and x1 will be the coordinates, which we already know, 1 and 2/3. M is the only one we don't know. Okay, and m is nothing but dy over dx at that point. the derivation, the differentiation of this will give us dy over dx. So let's differentiate this. We have numerator, let me write this here properly, okay? 2 plus 3 natural log x divided by 1 plus 2x. This was this, okay? I have typed it, so that's why it is not that visible. So this one. So we have u over v format, right? So what is our differentiation? It will be v squared, and here it will be u prime v minus u v prime. So v is the denominator, we'll square it first. So let me square it. 1 plus 2x square. Then we'll differentiate the numerator, which is 2 plus 3 natural log x. The differentiation of 2 is 0, so no need to write. 3 natural x, 3 will be 3. Natural log x, its differentiation is 1 over x. So the constant, if it is multiplying, we don't touch it. We just differentiate ln x, which is this. Then we want v. v is denominator. So 1 plus 2x will be multiplied with this. Minus u. u is the numerator, which is 2 plus 3 natural log x. I can write it x cube also. Should I? Let's write it. Okay, I will write natural log x cube. Just like previous question number 1, I am making this 3 as the coefficient. Alright, and then we write the differentiation of denominator. Differentiation of 1 is 0, so we will not write it. Differentiation of 2x is just 2. Alright. I could have simplified this, but I don't want to, because my purpose is to find m when x is 1. At this point, I want the gradient of the tangent. So just replace x equal to 1 in this whole of this. So 3 multiplied by 1 over 1. Now straight away I'm writing m at x equal to 1. 3 and 1 plus 2 times 1 is 3 again, minus natural log of 1 cube. First let's make 2 times 2 is 4, minus 4, and 1 cube is 1, so natural log of 1 is 0. Rather, log of any base 1 is 0, so I will not look at this. Just 2 times 2 is 4. Okay, and 1 plus 2, okay, 1 plus 2 times 1 is 3, so it will become 3 square. Answer is 9 minus 5, which is minus 4 is 5, 3 square is 9, 5 over 9. This is the gradient of tangent at this point, and now we have everything in this equation. Let me write this in simpler form now. This one becomes y minus y1 given to us 2/3 equal to m is known to us now 5 over 9. Okay, x minus x1 is 1. Okay, now we have denominator 9 here, denominator 3 here. So to get rid of denominators, let's multiply by their LCM, which is 9. I'll multiply the whole equation by 9 so that I can take care of these denominators, and because my format has to be this. Yeah, so 9 times y is 9y minus 9 times 2/3 will be 6. You can use your calculator. 6. Alright, equal to 9 times 5, 9 will be just 5. And since this is also multiplying, we don't have to multiply 9 with this. Only one of them can be multiplied. So 5 will remain, this 9 will cancel with this 9. So 5 times x is 5x. 5 times minus 1 is minus 5. Okay. So they want this format and 0 on the right side. That means everything should come to the right side. So it will be 9y minus 5x minus 6 plus 5 equal to 0. So 9y minus 5x minus 1 equal to 0. But they want x in front, and x is negative here, right? Whenever we want this to be positive, we have to multiply the whole of equation by minus 1 again. I'll multiply this by minus 1. So that this minus 5x becomes positive. So it becomes positive 5x, but this 9y will become negative, and this negative 1 will become positive 1. Everything will change the sign, and 0 doesn't have any sign. So this is the final equation according to the format they wanted. This is also done. No other part it has. So question number 3. It is given that the integration from 0 to a of this is 12, where a is a positive constant. Okay, show that a equal to this. All right, that means we'll have to integrate first. So let me integrate this first. Okay, what is the integration of 3? 3. Just we don't touch constants even in differentiation and integration, anyone. E to power 2x, this will be integrated now, so it will be e to power 2x divided by the differentiation of 2x, which is 2. Integration of 1 will be x, then we'll have c, and we want from 0 to a. So now we'll substitute 0 and a in this, and which is equal to 12. So 3 can't cancel, so we'll write 3 over 2 e to the power 2 times a. Yeah, in place of x, I'm substituting a, minus a plus c. This is substitution of a. Now 0 will be substituted. 3 over 2 e to the power 2 times 0 will be 0. So minus 0 plus c. First thing we should do, cancel out c's. And this is e to the power 1. E to the power 0 is e to the power 1. So equal to 12. Okay. 3 over 2 e to the power 2a minus a minus 3 over 2 only, right? Yeah, because this is 1, this is 0, gone, equal to 12. So what do they want? They want a to be separated. If I separate this a, I bring it here and 12 here, I will not get any natural log. That means I cannot isolate this a, I have to isolate this a. So first I will isolate this one, so I'll bring a and 3 over 2 to the other side, so it becomes 3 over 2 e to the power 2a here. A becomes positive, this becomes positive, and 12 was already here. Okay, so 3 over 2 e to the power 2a equal to a, and this will be 24 plus 3, 27 over 2. Now I have to get rid of this 3 over 2, so I'll multiply by 2 over 3 here and multiply this whole thing by 2 over 3. So they cancel out, we are left with only this. Let me complete it here. E to the power 2a is equal to 2 times a, so 2/3 a. And 2 times 27 is 54 divided by 6, which is 9. Now I want this 2a to become the main subject. That means I have removed e. When we remove e from one side, we have to find natural log of the other side. So 2 over 3a plus 9. And now we'll get rid of this 2 by dividing by 2 here and dividing 2 here, cancel out. We are getting exactly what they were asking us to show. They have changed the places, but in adding, it doesn't matter which is written first, which is written second. So we finally got a equal to half natural log 9. I'm writing first to match their requirement. We've shown this. Next, use an iterative formula based on the equivalent equation in A. Okay, this is the equation we got, this one. Okay, to find the values of 8, 4 significant figures and value of 1 we should start with. Give the result in each iteration to 6 significant figures. All right. So I will change this one to this one. an plus 1 equal to half. This is called iterative formula, when the one which was isolated becomes n plus 1 and the one which is inside or on the right side remains an only. So 9 plus 2 over 3 an. So if I take first value a1 equal to 1, they are saying that start with this a1 equal to 1. So put this value equal to 1, we'll get the value of a2. So it will be how much? Half natural log 9 plus 2 over 3 times 1, 2 over 3. Just put this in a calculator and you will get it. Let me fasten the video from here. I will keep on substituting the values here and we'll see what the answer will be. Okay, so every time I wrote 6 significant figures, 1, 2, 3, 4, 5, 6, 6 here, 6 here, and when I rounded them to 4 significant figures what they wanted, in these two parts we got exactly same value 1.139, and that becomes our answer. A is 1.139. This is the answer. Whenever two consecutive iterations give you same value, that becomes our answer. So this is the answer of part B. Question number 4. The polynomial this is defined by 2x cubed 3x squared kx minus 30, where k is a constant, given that x minus 3 is a factor of, okay, so if x minus 3 is a factor and we make it equal to 0, x equal to 3, this value will make the whole polynomial 0. I hope you understand. If I have 3 times 5 times 4 times 0, one of the factors is 0, the whole multiplication becomes 0. So if I make one factor equal to 0, which is x equal to 3, the whole polynomial will be 0, and that's what I'm going to do. I'm going to substitute x equal to 3 here. So P3 has to be equal to 0. 2 3 cube. Let me do it clearly. 2 3 cube plus 3 3 square. In place of x, I'm substituting 3. That will make it equal to 0, and that's what I'm writing, equal to 0. And k is the only one unknown here. That will give us the value of k. So 27 times 2, 54. 9 times 3, 27. Plus 3k minus 30 equal to 0. 27 minus 30 is negative 3. 54 minus 3, 51. Plus 3k equal to 0. 3k is equal to negative 51. K is negative 51 over 3 gives you negative 17. That is the value of k. Okay, what next? Hence, find the quotient of px is divided by x minus 3. So x minus 3 divides px, which was 2x cube plus 3x square plus 3x square plus now minus 17x plus 3x square minus 17x minus 30. Okay, plus 3x square minus 17x minus 30. Okay, so I'll carry out the long division. X and 2x cube compared. What should I multiply x so that I get 2x cube? 2x square I get. Okay, so it will be 2x cube and then minus 3 multiplied by 2x square will be minus 6x square. If I subtract, this will cancel out. This will become positive 3 plus 6, 9 x square, and they won't change any sign because they are already in the original one. Now 9x square and x, I need 9x. So 9x square minus 27x. 3 times 9, 27. Subtract, it will become positive, cancel, it will be 10x minus 30. And we need 10 now. X times 10 will be 10x. Minus 3 times 10 will be minus 30. Done. Completely cancelled when subtracted. Okay, so say they find the quotient of px and factorize completely. So this is the quotient. Let me write here. This is the quotient Now we have to factorize this also because they want to factorize px completely. So 2x square plus 9x plus 10 is a quadratic expression. I want to factor this and I will split the middle term to get it. 2 times 10 is 20. I factored 20 into two parts, which is 5 and 4. That will give me 9. Very good. 2x square plus 5x plus 4x plus 10. If I take the first two, the common is just x. So it will be 2x plus 5. I take common from the rest of the 2 will be 2. Just 2. 2x plus 5. If you split the middle term properly, you will never get it different. It will always be same. So x plus 2x plus 5 is the factor of this, x plus 5 because this, and x plus 2 because that was out. Alright, and now complete this set. So complete factorization will be, we already had x minus 3 given in the question. We got x plus 2 and 2x plus 5. The other two factors, I have factored this completely. Part C, okay, says what? It is given that a is the root of the equation px equal to 0. A is one of the root. The other previous one was k, right? Not a. Yeah, it was k. So this a thing is, alright, this is a different thing. So it is a factor of px equal to 0. So let me find these first. Okay. So first factor was x minus 3, second was x plus 2, third is 2x plus 5. Now I want to find roots. For roots, we have to make it equal to 0. So this gives us x, let me write here, x minus 3 equal to 0. So x equal to 3 is the first root, which was already given to us. Second, x plus 2 equal to 0. Now you know how to convert a factor into root. Okay, just make it that factor equal to 0. And then we have 2x plus 5 equal to 0. And this will give us 2x equal to negative 5, x equal to negative 5 over 2. They have not specified that which root is this a, either this or this or this. Okay, they have not said. But we know it is absolute equal to a. The absolute value of any expression, 4y minus 5 in this case, can never be negative. That means this root is ruled out, this root is ruled out, because both of them are negative. An absolute value can never be negative. So it has to be only this positive value 3, right? And to solve this, if this is equal to 3, that means inside this absolute sign, it was either plus 3 or minus 3. We are not sure what was it. So we'll take both the answers. So we'll take this equal to 3 and 4y minus 5 equal to minus 3 also. We'll take two of them because we are not sure what was inside, so that it became positive 3 outside. So this gives us 4y equal to 3 plus 5, y equal to 8 divided by 4, which is 2. And they're saying values of y. So that means this is the first value only. Second value will be 4y equal to minus 3 plus 5, positive 2 over 4, and y equal to half. This is second value of y. We got first value 2, second value half. All right. Number 5 question. The diagram shows the curve. Okay, we can see that this is the equation. Let me write that properly here. X equal to 4 e to the power 2t and y is 5 e to the power minus t cos 2t. All right. From negative 1/4 pi to positive 1/4 pi. The curve has a maximum point of m. We can see it is a turning point, stationary point. Find the expression for dy over dx in the terms of t. That means, in other words, they're saying differentiate it. Okay. So for dy over dx, we'll find dy first. And how can we find dy? If we differentiate y with respect to t, it becomes dy over dt. So we'll differentiate this. These two parts are multiplying, right? So we'll use product rule. 5 is untouched, keep it out. 5 is also multiplying. Whenever a constant multiplies, we don't touch it, we just keep it. So let's differentiate this one. I hope you know what is u multiplied by v prime. This is the differentiation. It is u prime v plus v prime u. Okay, so we have to differentiate the first one with e to power minus t. Its differentiation will be e to power minus t only, but divided by differentiation of the exponent, which is minus 1, and multiplied by cos 2t. Then plus, we'll keep this one the same, e to power minus t, but we will differentiate cos 2t. The differentiation of cos 2t will be minus 2 sine 2t. Alright, e to power minus t is common in both, so let's take it out. Dy over dt equal to, this is negative, so let's take negative also out. E to power minus t also out, 5 was already out. What is left? This minus is out, this e to power minus t is out, cos 2t is the only one left. This is out, negative out, 2 is left, so plus now, because negative has been taken out, 2 sine t, sine 2t. That's dy over dt. Let's focus on dx over dt now. That means differentiate this x with respect to t, and it is not multiplying, 4 is multiplying constant, so 4 will remain 4. E to power 2t is differentiation e to power 2t itself divided by differentiation of the exponent, which is differentiation of 2t with respect to t will be just 2. So this cancels out. Answer is 2 e to power 2t. But the question was not dx over dt or dy over dt, they were dy over dx, and we'll use chain rule in this. Chain rule is dy over dx will be dy over dt multiplied by dt over dx, so that dt and dt cancel, we get left with dy over dx. So first we'll write dy over dt, which is this one. So we will write dy over dx will be minus 5 e to power minus t cos 2t plus 2 sine 2t multiplied by the reciprocal of dx over dt. Because it is dx over dt here, we have to write dt over dx. That means we have to just multiply, let me give more space here, multiply by reciprocal of this. So it will be 2 e to power 2t. Is it cancelling something? Yes, it is no, not cancelling, but we can simplify this. So minus is minus 5 over 2, this 2, 5 over 2. Then e to power minus t is already here, and we can take this e to power 2t also, because the bases are e, so we can subtract 2t from this. And then cos 2t plus 2 sine 2t, okay, which becomes minus 5 over 2 e to power minus 3t cos 2t plus 2 sine 2t. And usually we don't leave exponents at negative, so let's make it positive. So it becomes minus 5 over 2 e to power 3t, and on top it will be cos 2t plus 2 sine 2t. That is dy over dx for you. Okay, what next? Find the coordinates of M. So we can see that M is a stationary point. The highest point here, its gradient, tangent gradient at M is 0, and which is nothing but dy over dx. That means dy over dx will be 0 for m and only m. Okay, there is no other turning point here, so let's make the one we got here equal to 0, this one. So minus 5 over 2, and let me write here, there is a reason for writing the same thing, so I'm writing the previous step, this one, okay, because this is, I'm making it equal to 0 for stationary point, and that will help. Cos t plus 2 sine 2t equal to 0. Yeah, it is for m, stationary point. So dy over dx has to be equal to 0. That means either this is 0, which is not possible, a constant cannot be 0, or this is 0, e to power minus 3t equal to 0. That's why I wrote it like this. This has to be equal to 0, not possible. Why? E to power anything will never make it 0. E is a constant. Constants, no power will give you 0. It can come close to 0, but it cannot become 0. So this is also not the answer. So this is the one which will be our answer giving part. So cos 2t plus 2 sine 2t is equal to 0. Cos 2t equal to minus 2 sine, or let me do the opposite way because I want a positive tan. So 0. 2 sine 2t equal to minus cos 2t. I'm taking cos to the right side, and nope. Okay, so let's divide both sides by cos 2t. Here also cos 2t. Also let's divide by 2 here and 2 here. Why? I do not want this 2 gone. Sin 2t over cos 2t is tan 2t. Cos 2t and cos 2t cancel, so we are left with minus half. That means 2t is equal to tan inverse of minus half. Okay, we know that in quadrants tan is negative in this quadrant and this quadrant, right? So 2t, just put tan inverse positive. Now we have decided the quadrants, don't put negative anymore. Tan inverse 1 over 2, that's it. Tan inverse 0.5 you can put in your calculator. That will give you this acute angle and this acute angle. That will give you the answer. Let me do this in my calculator, and by the time I do this, I would request you to like this video, share with your friends, and subscribe to Math United, because I think I'm the first person to answer this paper for you, that too on the demand of for my subscribers. Even though the views are not that much on paper 2, but still I'm making for you guys, so please subscribe to my channel. So what I get is 0.4636 in radians. Okay, change your calculator to radians if it is in degrees. Why? Because whenever you have pi, something range given in pi, let's see here, can you see minus 1/4 pi to 1/4 pi, that means they're talking about radians. So these are the two answers. So my first answer will come from here. I'll start from 0 and reach to this line, because they say minus 1/4 to positive 1/4, right? So I should get an answer somewhere here and somewhere here, but halving it, this 2t will half it. So we'll write 2t equal to this one is pi minus 0.4636. T will be pi minus 0.4636 divided by 2, and I'm sure it is going to be more than half, more than 1/4 of pi. So this answer is not going to be the right answer, because 0.78 something, 0.78 will be 1/4 pi, and this is going to be more than that. Surely, I'm not even looking at it, you can use your calculator. This one is the second one. So 2t is equal to, I'll go in opposite direction because it's allowed. They said minus 1/4 pi, so we can go to negative direction. So it will be negative 0.4636, and t is minus 0.4636 divided by 2, which is minus 0.2318. And if we want to give in 3 significant figures, answer will be negative 0.232. This is the only answer which is meeting our requirement. Shall we go to the next question? Okay. Number 6. Show that, okay, this integration is equal to this. So we have to integrate this basically. So show that. Okay, so let's separate them. I will talk about the limits, these two, later. I will just focus on this. Even 4 I am keeping out. Cos square 2x dx. I separated it, and then I will write this plus. There's nothing, only 1 is there, so no need to write anything. Cos square 1 over cos square x will be secant square x. This one is easy, dx. Okay, so we know this one is easy. The integration of secant square is tan x, so plus tan x plus c. This one is done. The problem is here. For that we have to do some legwork. What? We know an identity that cos 2a equal to 2 cos square a minus 1. So if I write cos 2a plus 1 equal to 2 cos square a, and if I divide by 2 both sides, this 2 will go. So cos square a is equal to cos 2a plus 1, and that's what we can use here. 4 as 4. If I compare this with this side, you will see that a is replaced by 2x in our actual question. So we'll replace this a also by 2x in its equivalence. So I will write integration again, no bracket, integration. So it will become cos 2 times, and a is 2x plus 1 divided by 2 dx. This we have to integrate. So let's write here, oh, this can cancel, this and this can cancel, so we are left with 2 integration of cos 4x plus 1 dx, and we already have tan x plus c. So 2, and let's integrate this one. Cos 4x, its integration will be sin 4x, positive sin 4x divided by 4, differentiation of the angle. Then plus 1 is integration will be x. C we have already written for the whole of it, so no need to write again. So plus tan x plus c, and this 2 is with only these 2. Yeah, okay. So they said show, we have to show. Now we have to substitute the values. So we can write one more bracket here and write values from 1/4 pi to 1/3 pi. I hope you understand that 1/3 is bigger than 1/4. Okay, so it'll, let me substitute one by one. 2 sine, I'll substitute this one first, 1/3. So it will become 4 over 3 pi divided by 4 plus 2 multiplies with x, and x is this, 2 times 1 over 3 pi, then plus tan 1 over 3 pi plus c, minus, we substitute 1/4. So again it will be, okay, this and this cancel, so I can write half only. Sine 4 times 1/4 pi over 2 plus 2 times 1/4 pi plus tan 1/4 pi plus c. First thing first, cancel c. Alright. Sine 4 over 3 pi, so let me write 1 over 2 sine 4 over 3 pi. I will just evaluate it with my calculator, and here we're getting 2 over 3 pi. Is it mating here? Alright, not yet. Then plus tan 1 over 3 pi. I know the value of tan pi by 3 is square root 3. Then minus 4 and 4 cancel. Sine pi. If you look at the graph of sine at pi, it is 0. So this thing becomes 0. This and this can cancel. 2 pi over 2. Minus pi over 2. This because this minus. Tan 1 over 4 pi is 1, so minus 1. Let me complete it here. Okay, so the value of this one I'm getting is negative square root 3 over 4 plus 2 over 3 pi plus square root 3 minus pi over 2 minus 1. And now if I solve this, I'll surely get what they're asking for us. I'm straight away writing it. You can verify with your calculators by using them. I'm also doing it the same, but I'm sure it will be this answer. Question number 7. A. Cos 7 cos theta plus 24 sin theta should be in this format. R is positive and alpha is between 0 and 90. Okay, given that the value is, give the value of alpha correct to 2 decimal places. Okay, first let's focus on this one, the one format they want. R cos theta minus alpha. Let's expand this. I will apply the cos A minus B identity given in the exam booklet, or rather in formula booklet, and that's what I'm going to apply here. So cos A minus B is cos A cos B plus sin A sin B. So I've expanded this one. So now if I expand the whole thing, it becomes this part. If I compare this part with, they have given 7 cos alpha. Let me write here 7 cos theta. The first part is equal to R cos theta cos alpha. So cos theta is here, cos theta is here. You can cancel this. That means R cos alpha is 7. Okay, let me write here R cos alpha is 7. Similarly, if I compare the second part, R sin theta sin alpha equal to the second part, which is 24 sin theta. So sin theta and sin theta cancel from both sides. R sin alpha equal to 24. So the format they want, into that, these are the two conditions, and if I call this as equation number 1 and this as equation number 2 and then divide equation number 2 by equation number 1, it will give me the value of alpha. How? Equation number 2, this one, R sin alpha equal to 24, divide by equation number 1, which is this. So I will divide left by left, so divide by R cos alpha. Since they are equal, we actually are indirectly dividing both sides by the same number. That's what it means. R and R cancel here, and sin alpha over cos alpha gives us tan alpha is equal to 24 over 7, and alpha is tan inverse 24 over 7, which I will use my calculator. By the time I do this, I request you to kindly like this video, share this with your friends who need help, and subscribe to my channel, Math United. Okay, so it came out to be about 73.7399 something, which we will round off 2 decimal places, which is 73.74 degrees. Okay, They're asking R? No, they're not asking R. But let's find out. R is easy to find. What we'll do here, we divided 2 and 1. Otherwise, we will add the square of 1 to the square of 2. So equation number 1, let's square this, which becomes R square cos square alpha. Okay, I'm not writing the 7 square and I'll write it on the right side. E plus 1 square will be R square sine square alpha equal to 7 square plus 24 square. So there's sum of their squares on the left side equal to sum of their squares on the right side because they are equal. So R square stays here, cos square plus sine square will be and theta alpha. I'm not writing the value of alpha yet because it will become 1, so there is no need. It is 49 plus 24 square, 576. This additionally I'm doing because in B part I think it will be used as they're giving us an equation. So R square, since this is 1, this whole thing I'll leave it equal to 625 and square root both sides. R is plus or minus 25. However, they have clearly said R is positive, greater than 0. That means the negative part is not needed. We will delete it. Okay. So they asked us to find alpha only. Additionally, we found R because in next part it is going to be used. Okay. Solve the equation. So we are solving this equation now. So in place of this, we'll write the new format, which was R cos theta minus alpha. Okay, so R is 25, cos theta is unknown, minus alpha we know now 73.74, yeah, 74, this one, equal to 18. Okay, so now we will divide both sides by 18, not 18, 25. We don't want 25. We don't want 25 here, so it cancels out. Theta minus 73.74 comes out to be cos inverse 18 over 25, right? And cos inverse 18 over 25, we can use our calculators for this, which will be cos inverse 18 over 25, 43.9455, which is 43.9455. 95. Let's let 95 because this 2 digits, so let's put it to 2 digits. Okay. So theta minus 73.74 equal to 43.95. So theta is equal to, it becomes positive when it goes to the right side, 73.74. 74 plus 43.95, which will be 9. 7 plus 9 is 16. 4 plus 3 is 7 and 11. Okay, and they're saying, okay, they have not said anything, so we'll round off to 3 significant figures. Rather, let's say 1 decimal place, degree. So 117.7 degrees. This will be the first answer. What about the second answer? We should know that in quadrant 1, cos is positive. 18 over 25 was positive, right? So that's why we took this answer, 43.95. Cos is also positive in 4th quadrant. Okay, so we'll start from 0 and go to this level. However, it may cross 360, but yeah, because they want up to 360 only. But let's see. So theta minus 73.44 is not 4474 equal to second answer. Second answer will be this will be 360 minus this 43.95. 360 minus 43.95 equal to 360 minus 43.95 plus 73.74. Obviously this is more than 43, so this is going to give us a greater than 360 degrees. that means we will not accept this answer. This answer is rejected, we can't accept it. For that matter, now we should do what? We should go negative. Let's go to negative zone, so that if I add 73.74, I come to positive zone, which will be more than 0. So I'll additionally do this one now. Theta minus 73.74 equal to negative, and this angle is 43.95. And when it goes there, theta equal to 73.7, yes, it is giving us a positive answer, which is more than 0 degrees. So yeah, it'll be 9792. So three significant figures will be 29.8 degrees. That is our answer, which is between 0 and 360. Perfect. So this is the answer. This is the answer. This is not the answer. Even though we spent some time on it, please always do ensure that you try all possible answers. Let's go to the next C part, and hopefully this is the final answer. As beta varies, the greatest possible value of this is denoted by y. Alright, what they mean by greatest value? Greatest possible value is possible when this whole denominator is the smallest, because 150 is fixed, right? It's a constant. As this one becomes smallest, the denominator will get the largest value for this expression. So this is v, okay, and this is greater than greatest when denominator is least, right? 50 is again a constant. That means 50 cannot change. That means this has to be least. 7 cos half beta plus 24 sine half beta has to be least. 150 and 50 cannot be changed, so we'll focus only on this. Their value has to be least. Okay, so what was our conversion? According to part A, it was 25 cos theta, which is half beta in this case, minus 73.74 has to be least. What is the least value of cos? If I look at the graph of cos, what is the least value of cos? Minus 1, right? That means the value of this has to be minus 1 to give us the minimum value. Yeah, so it will be cos half beta minus 73.74 has to be equal to minus 1. Again, 25 is a constant, can't change. Let's not focus on it. Okay, and least value of this is minus 1. Okay, and half beta minus 73.74 equal to cos inverse minus 1. Cos inverse minus, what is the angle here when it is minus 1? Angle is 180 degrees. So this is equal to 180 degrees. Okay, that means half beta is 180 plus, this will become plus when it goes with the 180, 73.74, which is 253.74 degrees. At this particular angle, the value of cos will be negative 1, this will become negative 25, and this expression 1 they gave us v, this will have the least value. So positive value of beta for which the value of v occurs, is denoted by v. Find the value of v and determine the smallest possible value of beta for which the value of v occurs. So we already found this, that is beta. Oh no, not yet, not yet. We have to take care of this also. So control, I have to undo this. So beta will be twice of this, which is how much? 74, 8, 507.48. That is the value of beta. And now they're saying find that value v, determine the value of v, and that's what we're going to do now. So what will be that value? 150 divided by 7 cos half, and beta value is 507.48. Okay, plus 24 sine half 507.48 plus 50. Let's put this in our calculators and see how much I get. By the time I do this, I would request you to like this video, share with your friends, and subscribe to Math United. What I'm getting v after putting this in my calculator is 6. This is the value of 6, and the value of beta was not 253. Value of beta was 507.48. If you want to, in degrees they said, so it has to be up to 1 decimal place. So 507.5 degrees is the value of beta, which gives us value of v equal to 6. That concludes this solution video. I hope you liked it. If you did, give it a thumbs up and subscribe to Math United. Thank you so much.